Okay, now to answer the question, why do I even care about any of this? We're going to use trig ratios to find side lengths. This comes in handy I know I use these examples all the time, but it comes in handy in construction, it comes in handy in landscaping. It's good for engineering. Like, this is just, I mean, really, triangles are everywhere. So let's take a look at this. We need to find the value of W to the nearest tenth using the principle of have and need. What this means, have need, means that you ask yourself, what is it that I have? What information do I know? And what information do I need? So, for instance, let's look at example A here. What we have the side length of 17. We know that that is the hypotenuse. So I'm going to go ahead and highlight our hypotenuse friend. And what do we need? We're looking for the length of W, the value of W. Is W opposite or adjacent to the angle that we have? This angle, by the way, this guy, it's going to help us. This guy's going to be our best friend. Okay, we are looking, this one is the adjacent leg. The W we need is our opposite. Now you may be wondering why we're not just using Pythagorean theorem. The answer is because we only have one side value and we don't have any proof of congruence between the two legs. So we can't use Pythagorean theorem. We will need to use our trig ratios. Okay. We have the hypotenuse. We need the opposite. Now we think through our SOHCAHTOA and we figure out which trig ratio has hypotenuse and opposite in it. Okay, that is sine. Hopefully you figured that out. Sine has opposite and hypotenuse. So what we're finding is the sine of 54 degrees. So that's going to be written like this. It's just like finding the sine of x, except for x has an actual value now. We're not just using an arbitrary angle. We're using sine of 54 degrees. The sine of 54 is going to be equal to the opposite leg, which is W, over the hypotenuse, which is 17. So we've got sine of 54 equal to W over 17. Now we're going to solve for W. It's just like any linear equation, except you just leave sine of 54 where it is. Pretend that it's a number, even though we don't have that number yet. Just pretend it's a number. The first thing we need to do, well, and really the only thing we need to do, we need to get W by itself. The opposite of division is multiplication. So we multiply by the denominator so that it will cancel out. So I'm going to multiply by 17 on both sides. And 17 times the sine of 54 is going to be equal to W. Okay, you may be lost right now. Finish writing that down. I'll be back with the calculator. Okay. If you still need time to write down, pause the video. So now we have W equals 17 times the sine of 54. And we're just going to enter that into our calculator exactly like it's written. So we're going to push 1, 7, Then we're going to push the sign button, the one that says sin, right there. And we need the sign of 54. Then we close our parentheses. And we hit equals. We're looking for the value of W to the nearest tenth. So we find the value of W to the nearest tenth. If you look at the calculator screen, can you see the calculator screen? I think so. If we round this to the nearest tenth, then it becomes W equals 13.8. My pen. Okay, pen was struggling for a minute. This says 13.8. Even though it doesn't look like that's what it says, that's what it says. Okay, that's better. Now we're going to move on to B. If you still need time on A, pause the video. Okay, I'm going to leave space for us to look towards example A to figure out what we need to do for example B. In example B, we have this angle right here, this 28-degree angle. Now let's figure out what we have. So first off, our hypotenuse is right here. We don't have the length of the hypotenuse yet. But we do have the length of the opposite leg and the length of the adjacent leg. Well, we don't really have the length of the adjacent leg, but we're looking for the length of the adjacent leg. So we need to think in our brains, we need to flip through all the files in our brains and figure out what is the length. How do we find the length of the adjacent leg? What trig ratio uses opposite and adjacent? While you're thinking about that, I'm going to go ahead and write have opposite, which is 1.0, and we need adjacent, which is W. Okay, hopefully you had enough time to think through it. We're looking for the TOA part of our SOHCAHTOA, which is tangent. We know that the tangent of 28 is going to be equal to the opposite leg over the adjacent leg. So opposite over adjacent, which is going to be 1.0 over W. Okay, I'm going to rewrite that down here so you can see it a little bit better. This one's a little trickier than our last example. Okay, we need to get W by itself. But the question is, how do we do that? The answer would be, we're going to multiply both sides by W to get it out of the denominator. That's the first step, is get W out of the denominator. So W times the tangent of 28 is going to be equal to 1.0. Now we need to get W by itself. So we're going to divide both sides by the tangent of 28. And we have W equal to 1.0 divided by tangent 28. I'll give you a minute to write that down. We'll zoom in so you can see it a little bit better. Okay, so bringing the calculator back into the game. Okay, we're going to zoom out. Okay. Here's my calculator. Let me clear the last problem. We're just going to plug this into our calculator. So we have W equals 1.0. You technically don't need to put the 0.0, but we will just for consistency. We need to divide that by the tangent of 28 degrees, and we're going to close it. We're going to hit equals. Again, we want to round it to the nearest tenth. So we're going to round 1.8807 blah, blah, blah to the nearest tenth. This is going to equal, so W equals 1 point, all that crap, which gets rounded to 9. Okay, now it's time for example C. I'm going to walk you through what we have and what we need, and hopefully you guys can work through it yourself. Okay, we're looking at this 33-degree angle right here. This is the angle we're focusing on. We have our hypotenuse. And I'm not even going to highlight the one that we don't need. So we're looking for this W here. W is the, wrong color. Okay, so opposite is this one. We need the adjacent leg. Okay, we have, that's a W. Awkward. We have H, which is 4.5. And we need A, which is W. Okay, now you need to think through what trig ratio has A and H, and you're going to plug it in like we did for all the rest of these. You're going to work on that example on your own. Give yourself 2 minutes. If you need more than 2 minutes, go ahead and move on and come back to it.